Today you're going to learn about centers of triangles. The first one is the median. The point of concurrency of all the medians in a triangle is called a centroid. A centroid is always going to be found inside whatever type of triangle you have, whether it's acute, right, or obtuse. There is a special relationship between the centroids of a triangle, and the distance from each vertex to the centroid is 2/3 of the entire median drawn from the vertex. So this means that if you have example triangle ABC with median AM, CN, BP, that means that AX is going to be 2/3 of AM, and CX is going to be 2/3 of CN, and BX is going to be 2/3 of BP. So the next is angle bisector. The point of concurrency of all the angle bisectors of a triangle is called the incenter. An incenter is always found inside a triangle, whether it is acute, obtuse, or right. An example is triangle XZY, and in this case, line segment XC is an angle bisector. Line segment YA is an angle bisector, as well as ZB. They're angle bisectors. Therefore, because of those three being angle bisectors, all these are going to happen. Angle 1, it'll be the measure of angle 1 is equal to the measure of angle 2. The measure of angle 3 is equal to the measure of angle 4. And measure of angle 5 will be equal to the measure of angle 6. So the next one is altitudes. The point of concurrency of all the altitudes in a triangle is called an orthocenter. Orthocenters are located on the following. For an acute triangle, it is going to be inside the triangle. For a right triangle, the orthocenter is going to be on the triangle. An obtuse triangle will be outside. So for my example number 1, I have here an acute triangle, and as you can see, the orthocenter is located inside the triangle. So once again, your altitudes are BP because it forms a right angle on the opposite side of your triangle. This is also perpendicular, so CM is another altitude and AN is another altitude. The point of concurrency of all the altitudes is called an orthocenter. Okay, so my next example is a triangle that is a right triangle JOY. If you would notice, this side right here, which is a leg of your right triangle, is perpendicular to the other leg, which is OY. So JO serves as an altitude to triangle JOY because it is perpendicular to side OY. Also, OY is an altitude in reference to the side JO. So these two sides right here are serving as altitudes. And my last and final altitude is OB, which is perpendicular to JY. Guys, because these three are concurrent at this point, the orthocenter is that point right there. That is where the altitudes are concurrent. So my third example is an obtuse triangle LMN. So what I did was I had extended NM and made it a line or a ray so that I can draw the altitude LX. So after drawing the altitude LX, I extended it to where it reached this far. And so MY was my other altitude, but again, I had extended it where it is reaching this far. Again, this is ray YM going this far. And then ray and Z is perpendicular to LM or M, the line that contains line segment LM. And if I extend this, they are concurrent at point W. And so because they're concurrent at point W, that is my orthocenter. And once again, my orthocenter in an obtuse triangle is found outside the triangle. So my next center is the circumcenter. Circumcenter is the point of concurrency of all the perpendicular bisectors in a triangle. So what are perpendicular bisectors again? Perpendicular bisector is the line segment that forms a right angle and passes through the midpoint of a side of a triangle. It may be a line or a line segment. It could be a ray. It has to be perpendicular to the side of a triangle. So as an example, I have here triangle ABC, which is an acute triangle. And as you can see, this line XZ right here, is perpendicular to BC and also passing through the midpoint, meaning to say CZ is congruent to BZ. In the same way that my line XY or YX is my perpendicular bisector because it is passing through the midpoint of AB, and that makes AY congruent to YB. And so the same way with line segment XW, line XW, which is perpendicular bisector to AC, and it's perpendicular bisector because it forms a right angle with segment AC or side AC at the same time that AW is congruent to WC. Therefore, this center right here is called the circumcenter. So this right here is your circumcenter. My next example is a right triangle, so bear with me because there are a lot of lines already on this one. So this is my right triangle FUR, and my first perpendicular bisector, I'm going to call it as my line 1, is this one right here. Perpendicular bisector because this segment is going to be congruent to this segment right here, and it forms a right angle with side UR. My second perpendicular bisector, I'm going to call it as my line 2, is this one. This is perpendicular to side FU, and it's also a bisector because it passes through the midpoint of line segment FU or side FU, which means that this segment right here is congruent to this segment right here. My third perpendicular bisector is line 3, which is right here, and it is perpendicular to side FR. Perpendicular bisector because other than being perpendicular or forming a 90-degree angle, it also is passing through the midpoint of side FR, which means that this segment right here is congruent to this segment right here. As you can see, all my lines 1, 2, and 3, which are all the perpendicular bisectors of this given triangle, are concurrent at this point. Therefore, this point is called the circumcenter of right triangle FUR. For this last and final example, I have an obtuse triangle, which we are anticipating that the circumcenter is going to be found outside the triangle because it is obtuse. So at this point, I would like to share with you how to construct perpendicular bisectors. So in this case, side UV, I will first approximate my midpoint. Let's say that that's my midpoint. And so this is congruent to this one. I'm just going to go ahead and draw a perpendicular line passing through that midpoint. And so that is my perpendicular bisector. So that's the first one. I will call that as my line 1. My next perpendicular bisector, I'm just going to approximate this and say that this is congruent to this one. And I will try my best to construct a right angle that will pass through line segment or side LU. So I hope that my approximation is close. And then now I will try my best to kind of see the midpoint of this is approximately there. And so this now is congruent to this one. We're going to go ahead and make it to where it is forming a right angle. It does not have to pass through your vertex. That's not a required condition. So in this particular case, we have the perpendicular bisectors, lines 1, line 2, and line 3 concurrent at this point, and therefore that is called your circumcenter.